Limit as x goes to 7 of the square root of x minus the square root of 7 over 49 minus x squared. The first thing we're going to do is try plugging a 7 in for each of the x's. That will produce the square root of 7 minus the square root of 7 divided by 49 minus 7 squared. So that we will have the square root of 7 minus the square root of 7 over 49 minus 7 squared, which is a 49. The numerator, square root of 7 minus the square root of 7 is a 0. And the denominator, 49 minus 49 is also a 0. So we have the 0 over 0 indeterminate form. We will need to rework this. Since we have a root combination, a root involving the variable x in some way, added or subtracted together with at least one other term that's happening here in the numerator, we can use the root conjugate method. If both terms are a root, which is the case here, you still have a root conjugate. You still want the opposite sign between the two of them. For the root conjugate, we'll put it over itself. So we have a form of 1, and we do not change the value, just the look. We will be multiplying these with each other. In the numerator, those are root conjugates, so we will be foiling that out. First, root x times root x will be an x. Outside, root x times a positive root 7 will be a positive root 7x. They go together under a single root. Inside, negative root 7 times a root x will be a negative 7 root x. They go together inside a root as well. And then last, we have negative root 7 times a positive root 7, which will be a negative 7. All this over 49 minus x squared. Multiplying with root x plus root 7, we will not FOIL these out since these are non-conjugates. In the numerator, the outside and inside from the conjugate will cancel each other like they always should. We're left with limit as x goes to 7 of x minus 7 over 49 minus x squared times the square root of x plus the square root of 7. So we've taken care of the root conjugate multiplication. We have not yet removed the 0 over 0 indeterminate form. We still have that. In the numerator, we're getting a 0 because of the x minus 7. In the denominator, we're getting the 0 because of the 49 minus x squared. Those cannot cancel with each other just yet. We have to factor to be able to cancel. So that'll be our next step. We're going to be factoring. The numerator stays the way it is, but the denominator is a difference of squares, and we'll factor into 7 plus x and 7 minus x times the root x plus root 7. We can now see the factors as x is going to 7 that are making 0. They are here and here. Those do not cancel just yet. They're opposite signs of each other. Let's factor a negative out of the numerator, and that will make the 7 become a positive and x become a negative, which will make it match the form of the one we see in the denominator. And we can therefore cancel those factors out, leaving us with a 1 with the negative in the numerator. So we have limit as x goes to 7 of negative 1 divided by 7 plus x times root x plus root 7. Since we've removed the factors that we're making the 0 over 0, we should be able to retry plugging the 7 in for each of the x's. We will have a negative 1 divided by 7 plus 7 times root 7 plus root 7. That will give us negative 1 divided by 14. If we add those 7's together, and then 2 root 7 if we add the root 7's together. We can now multiply the 14 and the 2, so we will get negative 1 over 28 root 7. It's likely that this will be rationalized, since it should simplify after rationalizing. Rationalizing is where you multiply by the root that you see in the numerator or denominator, generally in the denominator, root 7. But we need to multiply the numerator and denominator by that, a form of 1, so we don't change the value just to look. In the numerator, we would have a negative root 7. In the denominator, we will have a 28 times the root 7 times the root 7, which is a 7. And so we end up with negative root 7 divided by 196.